Hello everyone. Let's take a look at a pretty interesting way that we can write the numbers 1 through 6. So let's start out by looking at the number 1. I claim that sine of pi over 2, that sine of pi over 2 is just another way that we can write the number 1. But what does sine of pi over 2 mean? Well, this is an angle, and it's in radians, okay? Pi over 2 is the same as 90 degrees. So if we have a circle, let's say we have a circle. Let's pretend that's a circle. And let's say the radius of that circle is 1. So if this is the center of that circle, from the center to any point on the circle, that's 1 unit. Okay? And let's consider this being like the XY plane here. This is your Y-axis, this is your X-axis. Well, any point on this circle, if it's an XY point, the X-coordinate corresponds to the cosine of that angle, and the Y-coordinate corresponds to the sine of that angle. So if we start here and we make a 90-degree angle, well, we're going to end, if this is the point, and we rotate it 90 degrees, or pi over 2, well, we're going to end up right here, right? And that point, well, where's that point? If this is the XY plane, this is the origin, and the radius is 1, right? So this point is at 0, 1. Well, the cosine, that means the cosine of pi over 2, or 90 degrees, is 0, and the sine of pi over 2 is 1. So the sine of pi over 2 is 1, so another way to write 1 is sine of pi over 2. All right, pretty cool. Well, how about the number 2? Well, I claim that we can just write 2 as, if we write d dx, this is basically a verb that says take the derivative. Take the derivative with respect to x of 2x. That's pretty simple. This is the same as x to the first power. So we can bring down that 1 and say 2 times 1 is 2 times, well, x to the 1 minus 1, or x to the 0. But anything to the 0 power is 1, so it's just 2 times 1, or 2. So the derivative of 2x with respect to x is 2. So if you want to write the number 2, we'll just write it as d dx of 2x. There you go. How about the number 3? Well, I claim that 3 can be written as, if you write det, which just stands for determinant. So we're taking the determinant of, well, this matrix, 5, 7, 1, 2. Okay, how do you take the determinant of a 2 by 2 matrix, right? It has 2 rows and 2 columns. Well, you just take this diagonal, the product of this diagonal, so 5 times 2, so 5 times 2, and then subtract off the product of this diagonal. So subtract off 7 times 1. So we have 10 minus 7, 3. So another way to write 3 would just be the determinant of this matrix. 5, 7, 1, 2. All right, let's move on to number 4. Now, you might be familiar with the capital sigma, right? The summation notation, where we have, let's say, n equals, say, 1 up to something. Say, well, I don't know, 1 to 3 of, I don't know, n plus 1. Well, you would just start with 1, so you plug in 1 for n. Whatever you get, then you write that down, and this is a sum, so you're going to sum up every term until you get to 3, and you're going to stop. Okay, but instead of the summation, we can have a product. And to do a product, we typically use this capital pi. This is the capital letter pi. The lowercase pi is pretty popular, but not so much the uppercase pi. But the uppercase pi can be used as a product formula. where we're going to start at n equals 1, and then we're going to stop at 3. And we're going to do the product of this, of n plus 1 over n. Okay, so what happens here? Well, we let n equal 1, so we plug in 1. So we get 1 plus 1 is 2. 2 over 1. So that's just 2. So we do 2, but then we multiply. So it's 2 times what? We plug in 2. So we got 2 plus 1 is 3, and then 3 over 2, right? Wherever you see an n, now you plug in 2. So it's 2 plus 1, 3 over 2. So that's 3 over 2. That's 3 halves. And then we're multiplying, right? So it's a product now. So every time we multiply, what you get when you plug in 3. Well, 3 plus 1, that's 4 over 3, right? There's 2 n's, so wherever you see an n, you plug in 3. So we've got 3 plus 1 is 4 over 3, and then we stop, right? N equals 1 to 3. So we got the 3, and we stop, and what's this product? Well, 2 times 3 halves times 4 thirds. This is actually just a 2 over 1, right? And you got some simplification. The 2's are going to cancel here. The 3 is going to cancel here. And you're left with 4 over 1. Or 4. Or 4. So another way to write 4 is just the product of n going from 1 to 3 of n plus 1 over n. Pretty cool. How about the number 5? Well, I claim the number 5 is written right here. The square root of, and again, a square root inside of the square root. So you have the square root of the square root of 7 squared plus 24 squared. What is that going to be? Well, let's see. We have the square root of, and another square root. Well, 7 squared is 49, right? And then plus 24 squared. What is 24 squared? 24 squared is, I believe, 576. Okay, so we have the square root of 576 plus 49. Well, that's 625. So what's the square root of 625? That's 25, because 25 times 25 is 625. Okay, so we have the square root of 25. Oh, but that's 5. So 5 is just, here's another fancy way to write 5. And how about the number 6? Well, I say 6 can just be a really excited 3. A really excited 3. 3 exclamation point. Well, this exclamation point is actually a factorial. What does a factorial mean? It just means you take all the numbers, all the integers less than where you start down to 1, and you multiply them all up, right? So 3 factorial is just 3 times 2 times 1. And that's 3 times 2 is 6 times 1 is 6. So there you have it. The numbers 1 through 6. Written a little creative. All right. I'll see you guys later.